Okay, this is chapter 1, day 5 for the AP stats. And we're going to walk you through this. This is actually really simple to do. So the video itself will not take very long, but it's possible that you may stop and write. So we're talking about transformations. So mean, median, mode, and then the 25th percentile Q1 and the 75th percentile Q3. And then the measures of spread over here, range, biggest to smallest, IQR, which these are related, right? That's the 75th minus the 25th. Standard deviation, which is the most famous measure of spread. It's how far on average each individual observation is from the mean. And the variance is the square of the standard deviation. It's the standard deviation squared. It has a meaning, but it doesn't really need to be discussed a whole lot. But the word does come up in our course, so I end up talking about it, even though it really isn't that necessary. Let me erase this in. Okay, so now if you have a set of data, okay, let's say the set of data is test scores, and they are 1 through 100. Okay. So you got some kids that are scoring a 60, some kids scoring a 90, 85, whatever. Now, if you add or subtract a constant, we'll call that K. I know it should be C, but K. Add or subtract a constant, then the mean will just go up and down by that constant. Okay. So if you had the numbers 1, 2, and 3 in a data set, obviously the mean is 3. If you added 5 to each data set, then the mean would be 7. Okay, that's pretty simple. The median's the same way. In this case, the median is also 2. And if you add 5 to each data set, then the median would be 7, just plus or minus whatever that number is. The same with mode and the same with Q1, Q3. Look at it this way. It's like a box plot, and there's a whole story to go along with it. That's kind of economic theory. Let's say here's the box plot of economic data for the United States. Here are the rich people on the far right, the poor on the far left. The middle is that line. Okay. Now, if the government decides to give everyone like $500, this happened during COVID, where they kind of gave, didn't quite do that, but for purposes of this conversation, we give everyone $500. All that happens is that box plot of average income just moves up $500. The shape doesn't change. It doesn't become elongated at all. It just rises all boats, so to speak, if it was like a tide. Okay. Now, and when you get into scaling things like multiplying, that's different. We'll talk about that with economic theory too. Okay, let me get this all erased here. So when you, let's say we multiply or divide by a constant, that would be here, multiply or divide by a constant. If you do that, then the mean is going to jump by that factor. All of these will jump. Let's take that same box plot, okay? And let's say for some reason, inflation, something happens and we double everyone's salary. We double it. Well, that is going to spread out the box plot like you wouldn't believe. Look at that. It's going to spread really far out. It's going to get a lot wider, okay? Let me move my picture over so you can see what my hands are doing. There we go. That's going to get a lot wider. There we go. Okay. So that's the scaling of it. Now, it's the same thing with economic theory. If you cut everyone's taxes by 5%, the rich do a lot better in that situation because they have 5% means more to them than the poor. So those are kind of the how you would look at this stuff with economic theory. Okay. And different people, there's different people in our government that look at things differently. Like, do we give everyone a little bit of a help on their taxes, or do we do by percentages? And it makes a big difference. Okay, measures of spread are the same thing, which is interesting. Let me draw this box plot again. So let's say you got a box plot right here. if you add or subtract a number to this box plot, now look at my hands on the screen, all you're doing is moving the box plot up if you add or subtract. So this box plot just gets moved up, but it's the exact same shape. It goes from here to here. It doesn't make any difference. So the range doesn't change because both the high number and the low number went up by the same number. So it doesn't change. The IQR won't, standard deviation won't, variance won't. However, if you multiply or divide by something, look at my hands, that box plot's going to spread out, and it's going to change all of these numbers by the factor of dividing by k or multiplying by k, depending on what you did. Okay? So all of that is a long explanation for something that's actually fairly simple. It takes maybe take a little bit longer to pause the video and write stuff down, but it's not super hard. Okay. So get the mouse here. Now, let's do this. Here is a 5-number summary of some data. The mean is 8.2, standard deviation 1.1, minimum 6. You got the idea. Okay. So we got the 5-number summary plus the standard deviation plus the mean. If you subtracted 5 from every number in this data set, and by the way, we do not know how many numbers are in this data set. It could be 20, it could be 100, it could be 1,000. We just have the summary data. But we do know if we subtracted 5 from each piece of datum, okay, you would get 3.2, this minus that minus 5, okay? The standard deviation would remain the same because all you did, look at my hands, is subtracted 5. You just moved the data this way. You didn't change how much it spread out. Okay. The minimum would go down, would go down 5. That's not even asked on here, but the median would go down to 3.5, 8.5 to 3.5. Q1 would go down from 7.3 to 2.3. The IQR, however, would stay the same because, again, walking in my hands, you got a situation where the data is moving down 5, so it doesn't spread out anymore. So the IQR, which is a measure of spread, stays the same, and the standard deviation also stays the same. Okay. Now, if you took some data and multiplied it by 3, watch my hands, that's going to spread the data out. Okay, multiplier spread things out. So the mean will get tripled. Okay. The median will get tripled. The max will get tripled. The range was maximum minus minimum. Max 6.9 minus the minimum 1.4. The range was, what is that? 5.5. You triple that because it got multiplied by 3. So there's the range. The IQR will also get tripled. It was 3, 6.7 minus 3.7. It was 3, but because of the multiplier, it got spread out. It's now 9. And the standard deviation will also get tripled. Okay? Again, pretty easy stuff. I'm spending a day on something that you really don't need a full day to do this. It's not super duper hard to do, but that's okay. All right. Okay. Let me slide down here. Now, outlier formulas. Okay, this is all done for us, which is great. Okay, so I don't have to write a whole lot on here, but this right there we go. Outlier formulas. Okay, so there are 2 outlier formulas. They sometimes produce different opinions as to what is an outlier. And by the way, there are really more than 2 outlier formulas. We just talk about the 2 that are in our book. There's other ones too. So the one for the normal curve, let's start with that one. So the one for the normal curve is X bar plus or minus 3 standard deviations. If your data is normal or symmetric or bell-shaped, this is a good one to use. Okay. Okay. So you have the mean right here. And if it's 3 standard deviations away on either side, beyond that, it'll be in the deep tails. That's going to be an outlier. Now, if your data is not normal, then you don't want to use this. You want to use this one. And this one has 2 parts. Q3 plus 1.5 times IQR, and Q1 times 1.5 times IQR. So let me draw this real quick. So we got, let's say we got a box plot, something like this. Let me make the box plot a little bit odd. Okay, something strange. So because the box plot's odd, we're not going to use this method. We're going to use this one. All right. So you got to go Q3, right where the arrow is, subtract Q1, and you got to triple it. Okay, whatever that is. And then you add it to this spot right here, and it runs this way, and anything beyond that is an outlier. And you subtract it from this spot right here from Q1, anything beyond it this way. Okay? So those are the two methods. I'm going to repeat myself. X bar plus or minus 3S is used when the data is approximately normal. This other one is used when the data is not normal. However, you can still use this data when the data is normal. A lot of people use this no matter what, which is fine. But this can only be used in one case. So whatever you want to do. Okay. And what will happen on the AP test is they will say things like, they'll say, are there any outliers? Justify your answer. And justifying your answer, all that means is show your work, show one of the formulas and put it in. And we're going to do that here. Okay. So if they ask that particular question, okay, here we go. So here's the data. Given the following statistics, all right, let's start with the standard deviation method right here. Okay. I have the work already done, but this is how you would do it. You would take 85.5 plus or minus 3 times the standard deviation of 13. And then if you do that, you're going to get this answer. Now, are there numbers beyond this? Yes, 127 is beyond this. And the minimum's 38. The minimum is also beyond this. Now, this is really important that you hear me on this. You would not put there are two outliers, 127 and 38, because this is just a summary. There could be thousands of numbers here involved. You would put there are at least two outliers that we know of, the max and the minimum. There could be others because anything past 124.5 is an outlier, and anything lower than 46.5 is an outlier. So do not say the minimum, don't just say the minimum and maximum are outliers. Say there's at least two outliers. Okay. Kids miss that on the AP test and they get partial credit. You definitely don't want that. Okay, let me erase this. Okay. There we go. Now, let's go to the other method. So you're going to go Q3 right here, minus Q1. That is 22. That's right here. You see it? And you're going to multiply it by 1.5 twice. And you're going to go 93 plus that sum and 71 minus that sum. So you get slightly different answers, 126 and 38. In this case, you would say only the max is an outlier. There may be more than 127, but that number is an outlier. 38 barely meets the requirement for not being an outlier. Okay. So the math on that's simple. You can kind of stop the video and just kind of go through that yourself, which should be easier to do. Okay. Now, this one. Okay. Let's do the standard deviation method first. Okay. You got 48, which is the mean, plus or minus 3 standard deviations. There's S right there. And it comes out 36 and 60 are the two barriers. So 36 is above 34. So the minimum is an outlier. And 60.6 is above this. So this is not an outlier. So again, don't say there is one outlier. Say there is at least one outlier, the minimum. There could be multiple 34s or there might be a 35 in there. We don't know. Okay. So make sure you don't just say there's one, there's at least one. Now the IQR method, let me draw this one out for you. Okay. The IQR method would be, let's see here, Q3, which is 53 plus or minus 1.5 times the IQR, which is 53 minus 34. Okay. And then it's also Q1 34 minus, whoop, I messed up. This is not supposed to be a minus here. Let me fix that. Good error. 53 plus, there we go. 53 plus 1.5 times IQR and 34 minus 1.5 times IQR. Okay. And when you get that, you end up with the barriers of 28 and 68. So in this case, this method shows that there are no outliers. So there is a discrepancy. Does it matter which one you use? Well, like I said, if you're going to use this method, make sure it's normal. Okay. And in this case, does this data look normal with them? The mean is 48.3, the median is 51. That's pretty close to normal. Okay. You want to make sure they're the mean and median are about the same spot. Or if you draw the box plot, look at my hands, it's approximately symmetric. Most people just use this one only. Makes it a little bit easier. Okay. Let me resolve this. Sorry about that little delay there. There we go. Okay. Now, resistant, non-resistant. This is the end of the lesson here. Resistant, non-resistant. Resistant means the values are profoundly affected when there's an outlier. Okay. So these are the items that are non-resistant. Okay. The mean is non-resistant for sure. The range is non-resistant, and the standard deviation is non-resistant, and the variance. Okay. When you add a crazy big or a crazy small number, those numbers will go nuts. Think of it this way. LeBron James scores 24 points in game 1, 24 points or 25 points in game 2, 25 points in game 3. After 3 games, he's averaging 25. And then he explodes for 68. Well, what has happened is that's going to make the mean, look at my picture, go crank way up. Okay, it's going to pull the mean to the right. Okay, it's going to make the range a lot bigger. Okay, it's going to make the mean range a lot bigger, and it's going to make the standard deviation a lot bigger. Now, the median will not move a whole lot. It went from 25 points median after 3 games to 25.5, the middle of the 2 middle numbers, after 4 games. And the mode didn't change at all. That's also resistant, and the IQR was resistant as well. So the mean, range, standard deviation, they go bunkers when there's an outlier. And that makes a difference. That is why when people talk about housing prices, they always report, if you can look this up, the median house price. If they reported the mean house price, some guy on the corner could build a mansion and would make the whole neighborhood look a lot wealthier when it's really not. Okay, so that's the reason for that. Okay, so that is Chapter 1, Day 5. Hope that helps. Stat Nation out.